Hello. In this video, we will look into how we can assess the environmental impacts of materials and buildings, which can help us make better decisions on the road towards achieving sustainability and carbon neutrality. The globally used method to assess and compare environmental impacts is commonly known as life cycle assessment, or simply LCA. LCA studies accounts for all the phases involved in a product system, from the extraction of raw materials, the processing, manufacturing, transportation, as well as the potential emissions involved during the use phase. And if you are applying a cradle to grave approach, you should also consider the end of life scenarios. LCA framework is an internationally standardized and iterative method that follows four main steps. First, the goal and scope definition, where the objective of the study and the system boundaries are defined. Second, the inventory analysis, where flow diagrams are built in order to determine the processes involved with the product system. Followed by the impact assessment, where the inventory is translated into the several environmental impacts. And lastly, the interpretation step, where the LCA results are assessed in terms of completeness and robustness. To compare between possible alternatives, inventory analyses are compiled to account for all the resources and emissions associated with the life cycle of the system assessed. It is important to mention that when assessing the environmental performance of buildings, we will be referring to European norms that describe specific groups of processes, which we call modules. Module A covers the product and construction stages, Module B covers the use phase, Module C covers the end-of-life scenarios, and Module D looks at the emissions and impacts that are outside of the selected system boundary. LCA studies rely on impact assessment methods to translate the inventory of each of the product systems assessed into the environmental impacts. There are many types of environmental impacts considered, including climate change, water acidification, and resource depletion, among many others, and this can be linked into the different areas of protection that are identified as priority. These are human health, ecosystem quality, and the availability of natural resources. During the interpretation phase of LCA, different analyses can be performed to help provide more informed results. These are, for example, contribution analyses that can help identify key processes within a product system, while uncertainty analysis can provide some perspective on the level of accuracy of the results. Sensitivity analysis and additional measures to assess consistency and completeness can be used in LCA studies to answer questions such as, how are the results influenced by the databases and the geographical scopes considered? How do model assumptions influence these results? Now that you are familiar with the LCA framework, we will look into how LCA results would be applied to a practical example.